Welcome to Study Loop.
Our question says, an airplane is heading due south at a speed of 580 kilometers per hour. If a wind begins blowing from the southwest at a speed of 90 kilometers per hour on average, calculate A, the velocity, both magnitude and direction of the plane relative to the ground, and B, how far from its intended position it will be after 11 minutes if the pilot takes no corrective action. I wrote out here what we were given, which was the velocity of the plane, v sub p, is equal to 500 kilometers per hour. And it said it was due south. And I'm going to call south the minus j hat direction. Okay. And then it says the velocity. And that's in the j hat because the minus sign came out front, plus 90 times the cosine of 45, because theta a is 45, and that is in the I hat, plus 90 times the sine of 45, and that's in the j hat. I'm kind of intruding on our graph here, so let me bridge the two with this green line here. So it's going to separate our graph and what was given here from the solution. Let's just carry that all the way across. Okay. And then let's also not forget our units here. So all of these are in kilometers per hour. Okay, and you can only add like components. So the j hat components can add and the I hat components can add. And so if we carry out these calculations and add like components, we find v of p prime is equal to 63.6, and that is in the I hat, minus 516 in the j hat. Okay, and both of these are in kilometers per hour, so put that on the outside. All right, and all of this that we're solving here is actually part A, so maybe we should just write A off to the side here. This is all part A. Okay, but we weren't asked to just find v of p prime vector. We want to find the magnitude and the direction. So first, let's find the magnitude of v of p prime, which is represented by these bars here. And that's going to be equal to the square root of the sum of the squares of both sides that make up v of p prime. So you'll have 63.6 squared plus minus 516 squared. You square a minus, it becomes a plus, so we can just ignore the minus sign. So this is 516 squared. And this is all in kilometers per hour. Okay, if you carry out that calculation, you find it equals 520 kilometers per hour. That is the new speed. So we did lose a little bit of speed if you compare the magnitude of v of p to the magnitude of v of p prime. Okay, but we also don't just need to find that. We'll box that in because that's part of our solution for A. We're also asked to find the angle. Well, the trig identity is the tangent of theta is equal to the opposite over the adjacent. So the opposite would be 63.6, and the adjacent would be 516, and those are both kilometers per hour, so the units will cancel, so we can ignore those units. Okay, and we're trying to find theta, so let's go ahead and solve this for theta. Theta is equal to the inverse of the tangent, which can be written as tangent to the minus 1 of that ratio, 63.6 divided by 516. Okay, and if we plug that into the calculator, we find that this comes out to be 7.0 degrees. And let's indicate what direction that is. That is 7.0 degrees south of east. So we'll write south of east. Okay. And then for part B, we're asked to figure out how much the plane then has deviated if the pilot doesn't correct for the fact that this wind is blowing it slightly off course. Okay, so let's go to another page here to find that, and we'll indicate that this is part B. Well, it tells us that the pilot doesn't do anything for 11 minutes. So T is equal to 11 minutes. Okay, and we can use the fact that the distance is equal to velocity times the time. So the distance difference, we'll just call that d, is equal to the velocity that it's traveling times the time. V sub t, velocity times the time. Okay, well, the velocity we're going to be using is the magnitude of the plane that we found on the previous page. So that's 520 kilometers an hour. So 520 kilometers per hour. But you'll notice we're going to run into a problem here because our velocity is in kilometers per hour and our time is in minutes, because this is going to be multiplied by 11 minutes. So actually, in order to carry out this calculation, we need to convert minutes into hours. And we can do that by realizing that 1 hour is 60 minutes. So we multiply by that conversion, and that will allow us to carry out this calculation. So if you plug all this into the calculator, you'll find that it varies off course by 16.5 kilometers if the pilot does nothing to correct. We'll box it in as our solution to part B.